In recent years, there is a demand for improvements to the durability of tunnel secondary lining. For this reason, we have improved the durability and economical efficiency of tunnel secondary lining through a combination of lining technologies that we have developed. The technology proposed this time is a system comprising a wet mist curing system, a pouring control system installed onto a secondary lining movable formwork, and an air partition balloon that blocks the wind after penetration. This provides a well-made finish for the completed tunnel and also reduces the rate of cracks occurring by 90% when compared to existing techniques. Now, let's take a look at and compare the lining method proposed here with a lining method that is generally used. The general method for lining tunnels using the new Austrian tunneling method involves pouring concrete from inspection windows positioned on the formwork into the sidewalls and up to the arched section. Concrete is then poured into the crown part. The amount of concrete poured into the crown part at this point is about 50 cubic meters. About 2.5 to 3 hours is required for the time to pour concrete into the crown part, and it is poured using a concrete flow method. This method causes the often seen prominent stripes that lie along the inside of the tunnel at regular intervals. The most significant feature of the proposed lining method is the concrete pouring and compaction at the crown part. Float vibrators are used to compact concrete at the sides of the tunnel together with auxiliary vibrators to continue compacting consolidated layers. From the arched shoulder to the inspection windows on crown part, concrete is poured through the use of a crown part horizontal forced insertion system. This improves the filling properties by minimizing the pouring amount and pouring time for the crown part. The amount of concrete poured from the crown part is about 20 cubic meters or less, and the pouring time is approximately 1 hour. Crown part concrete pouring involves continued firm compaction of consolidated layers that were poured using a horizontal forced insertion system. Once concrete pouring is complete, a pulling out vibrator system is used to compact the crown part. You can see that the proposed method requires lesser amount of concrete pouring at the crown part compared to the general method. The fill pressure monitor system visualizes the pressure in real time through sensors placed several locations on the surface, which helps you to control concrete pouring. For the general method, pouring is completed by visually checking from the end plate side. The fill pressure at this time is roughly around 36 kilopascals at the lap side and 10 kilopascals at the gable side. The initial fill pressure at the crown part for the proposed method is the same as the general pouring method. The difference is that concrete continues to be further forced in to fill the area from the point that pouring would normally be over. The final fill pressure is on average 74 kilopascals for the lap side and 33 kilopascals for the gable side. For the difference in lap and gable fill pressure, the fill pressure is averaged to 54 kilopascals at the lap side and 30 kilopascals at the gable side by compaction, using a pulling-out vibrator at the crown part. The fill pressure difference at the crown part for the general method and proposed method would be about 20 kilopascals. Densely filling the crown part reduces cracks and produces secondary lining concrete with a superior uniform quality in terms of durability. During the curing process after lining, sufficient wet curing is performed by spraying mist at high pressure within an airtight sealed space covered with a sheet. The sheet extends over 31.5 meters and allows wet curing to continue for a week. Humidity in the space is maintained at around 90% and has been shown to be effective. General method often produces prominent stripes that lie along the inside of the tunnel at regular intervals on the crown part. This is because after the pour, the concrete needs to flow a long distance before placed, and a fairly large amount of time it takes to complete the pour. The proposed method provides a clean and smooth lining concrete finish because concrete is poured horizontally up to the crown part without flowing. Gifu Industry Company Limited aims to construct lining concrete that has even better workmanship and is superior in terms of durability to fulfill customers' needs, and continues to make great efforts in developing systems for lining technology.